I want you to picture a scenario that I am almost certain you've lived through. You navigate to this massive, just beautifully designed corporate website.
Oh, yeah. The ones with the buttery smooth animations.
Exactly. The graphic design is stunning. The typography is super modern. The micro animations as you scroll are, like, perfect. It looks like it just won a handful of industry design awards.
Right. But you aren't there to look at the art.
No, not at all. You are there to execute one highly specific, incredibly simple task. Like, maybe you just need to find the warranty policy for a monitor you bought 3 years ago.
Or you want to download a white paper on their new software.
Right. And despite the, I don't know, millions of dollars poured into this site's design, you find yourself completely hopelessly lost.
It's an incredibly isolating feeling. It's kind of the digital equivalent of wandering into the Louvre or the Met, except none of the wings have directional signs.
Oh, man. That sounds like a nightmare.
And none of the individual paintings have those little informational placards either. And the map they handed you at the front desk, it's written in a localized dialect you don't even recognize.
Yeah.
You know the masterpiece you're looking for is in the building somewhere, but the building itself is actively fighting your attempts to find it.
That is exactly it. So you click on a top navigation menu, and a mega drop-down appears with, like, 36 vaguely named options.
And you just give up on the menu.
Totally. You think, okay, I'll bypass this and just use the search bar. So you type in monitor warranty, and the internal search engine spits back 500 entirely irrelevant results.
Let me guess. Prioritizing a blog post from 2019 about the CEO's vision for customer service.
Yes, instead of the actual PDF you need. So you end up frustrated, you abandon the session, and, well, if you have any other choice in the market, you probably never do business with them again.
It's a massive loss.
It is. That friction, that immediate evaporation of customer goodwill is the invisible cost of digital clutter. And that is the foundational thesis of our deep dive today.
Because what you're experiencing in that frustrating moment is, well, it's rarely a failure of graphic design or copywriting. The aesthetic layer is usually fine.
Right.
What you are experiencing is a catastrophic architectural failure. It's a failure of how the underlying information was categorized, semantically linked, and presented to both the human eye and the machine crawler.
We build these beautiful digital facades, but behind the drywall, the wiring is just a chaotic, tangled mess.
Exactly.
And today, Monday, March 23, 2026, we are pulling our source material from someone who acts as a structural engineer for that digital wiring.
Yes, Alexander Rodriguez Silva.
Right. We're dissecting the second part of a really comprehensive article from the Semantic blog by information architecture expert Alexander Rodriguez Silva. And what's so compelling about Silva's work is that he tackles the exact infrastructure that most of us never think about until it completely breaks down.
He is literally mapping the hidden architecture of the web.
And he's incredibly rigorous. So the mission of our deep dive today is to extract a highly practical summary of his semantic implementation checklist.
Because this isn't just abstract theory.
Not at all. Whether you're managing the digital footprint of a massive global corporate portal or, trying to untangle a mid-sized e-commerce taxonomy.
Or just trying to figure out why your company's internal wiki feels like a black hole where documents go to die.
Yeah, exactly. The principles remain the same. We are looking at how to fundamentally organize and structure digital projects for the current age of artificial intelligence.
And we really need to start right there with the AI aspect. We have to contextualize why this specific conversation matters so intensely right now in 2026.
Because if you work in digital management, you know that navigation isn't just about giving humans a pretty row of buttons anymore. Navigation is the visual, interactive manifestation of a deeply complex taxonomy.
Right. But what does that mean when the primary user reading the taxonomy isn't a human but an algorithm?
It changes everything.
It changes the entire paradigm of web development. Think about the current era of search and information retrieval. We aren't just optimizing for traditional search engines that look for, keyword density anymore.
Right, we're dealing with generative AI search agents, answer-based algorithms, large language models.
Exactly. And they are actively trying to read, parse, and comprehend the relational context of your entire site. So in this environment, a well-architected internal link structure does something absolutely critical from a technical standpoint.
It intelligently distributes your crawl budget.
Yes.
I'm so glad you brought up crawl budget because it's one of those terms that gets thrown around in marketing meetings, usually by people who don't actually understand the math behind it.
Oh, constantly.
But let's clarify the mechanics for everyone listening. Search engines do not have infinite server racks dedicated exclusively to your company.
They wish.
Right. They allocate a highly specific, mathematically determined amount of time and computational power to crawl your domain.
Exactly. Googlebot, or any AI crawler, operates on strict resource constraints. The algorithm looks at your server log files, it looks at the historical PageRank distribution of your domain, and it assigns you a budget.
So let's put some numbers to it.
Okay, let's say it decides it has the resources to crawl 1,000 pages on your site today. If your architecture is a disorganized, cluttered nightmare, the crawler spends its 1,000-page budget getting trapped.
Trapped in what, exactly?
In infinite redirect loops, or reading duplicate localized pages, or crawling thousands of useless, automatically generated tag archives. It exhausts its budget before it ever reaches your newly launched, high-margin flagship product page.
Wow. So to put it bluntly, bad architecture actively hides your best assets from the machines.
That is exactly what happens. But if your internal architecture is solid, logically structured, and semantically clear, the crawler moves efficiently.
Right.
The most vital pages are indexed, understood, and ranked without your engineering team having to constantly manually submit XML sitemaps and beg the search engine to notice the new content.
And the beautiful secondary effect of this, and I think this is so cool, is that building a structure that a machine can easily parse mathematically, inadvertently, creates a structure that human users can navigate intuitively.
It's a win-win. The logic scales perfectly across both types of intelligence.
Which brings us to the first massive decision any organization has to make. Because before you can build a site that search engines and users understand, you have to choose a foundational blueprint.
You can't just open a content management system and start publishing pages willy-nilly.
Exactly. Think about urban planning. A physical city needs zoning laws. You dictate that high-density residential goes here, heavy industrial goes near the highway, and commercial retail goes downtown.
If you don't do that, you get a toxic factory opening up next to an elementary school.
Right. A large corporate portal requires that exact same level of premeditated zoning. It needs an organizational matrix to manage the massive flow of daily information.
Because without that matrix, you inevitably suffer from digital urban sprawl. Individual departments just start spinning up their own pages, creating their own chaotic naming conventions.
And the whole system eventually collapses under its own unstructured weight.
Exactly. Silva outlines 4 primary organizational models, heavily inspired by the classic Microsoft Information Architecture Framework.
And to really understand the strategic benefits and, honestly, the severe operational dangers of each, we need to look at how they function in the real world.
Okay, let's build a hypothetical sandbox to test these out.
I love that. Let's imagine we are the lead architects for a massive, multinational sporting goods conglomerate. We'll call them Apex Global Sports.
Sounds very corporate. I like it.
Right. We manufacture everything from golf clubs to yoga mats. We operate in 50 countries, and we have thousands of employees. So we need an intranet for our staff and a public portal for our customers. How do we structure this colossal digital building?
Well, model number 1 on Silva's list is the department model. This is where you zone your digital space based entirely on the company's internal mental model and culture.
So in the department model, the URL structure and the primary navigation menus are literal reflections of your corporate organizational chart.
Exactly. So for a fictional company, Apex Global, the root domain would branch off into subdirectories for human resources, information technology, global sales, corporate marketing, and legal.
It's an incredibly common approach, particularly for enterprise intranets, and it makes sense intuitively, right?
Oh, totally. The primary benefit is cognitive ease for the employees.
Yeah, if I work at Apex and I need a new laptop requisition form, my brain naturally says laptops come from IT, so I click the IT department link.
Right. And it also scales effortlessly in a corporate sense.
Sure.
If the CEO decides to spin up a brand new sustainability department, the web team just creates a new top-level folder called /sustainability and hands the keys to that new VP.
Super easy. But Silva is very quick to point out the massive governance nightmares hiding inside this model.
Yeah, the governance challenge here is severe, and it comes down to security and information barriers.
How so?
Well, when you build a site that perfectly mirrors your internal departments, you are digitally placing highly sensitive areas right next to public-facing ones. Imagine the HR department's digital space.
Oh boy. That folder contains what, employee social security numbers?
Social security numbers, disciplinary records, unreleased executive compensation packages. If your architecture is just one big department tree, you must rely on flawlessly executed, highly rigorous permission profiles.
Just to ensure that a simple inherited folder setting doesn't accidentally expose that HR data to the public marketing folder.
Or to an unauthorized intern in the sales department.
That's terrifying.
Yeah.
And from a purely maintenance perspective, the department model seems incredibly fragile because, well, corporate structures are rarely permanent.
Right. What happens when our fictional company, Apex Global, decides to restructure? Let's say the board decides that having separate sales and marketing departments is outdated, and they merge them into a single chief revenue office.
Oh, wow. If you're using the department model, that corporate restructuring triggers an absolute digital catastrophe.
It does. Your entire URL taxonomy is fundamentally hard-coded with the words marketing and sales.
Right. So your site structure might be apex.com/marketing/campaigns and apex.com/sales/enterprise. When those departments cease to exist in reality, those URLs no longer logically map to the business.
Exactly. So the IT team is forced into a monumental URL auditing project. They have to physically move thousands of pages to a new /revenue directory.
And they have to set up 301 redirects for every single moved page.
Yes. And if they miss even a fraction of them, they generate thousands of 404 broken links.
And as we established earlier with the crawl budget, hitting a broken link is the fastest way to make a search engine crawler instantly abandon your site.
You're burning budget for nothing. So the department model is deeply intuitive for your internal staff on day one, but it is structurally brittle the moment the company undergoes any kind of executive evolution.
Which leads us to the second blueprint, the geographic model. Instead of grouping by internal departments, you organize your digital real estate purely by region.
Right. So for Apex Global Sports, our top-level structure wouldn't be HR or marketing. It would be North America, European Union, and Asia Pacific. Every region gets its own silo.
Why would a massive portal choose this route over the departments?
The geographic model is almost exclusively driven by two massive modern realities: international legal compliance and localized search engine optimization.
Okay, let's look at compliance first, because if Apex is operating globally, it is subject to wildly divergent data privacy frameworks.
Extremely divergent. The General Data Protection Regulation, the GDPR in Europe, has incredibly strict mandates on how user data is collected, stored, and processed.
And those differ vastly from, say, the California Consumer Privacy Act or data localization laws in India.
Exactly. So by structuring the portal geographically, you aren't just creating a navigational menu, you are facilitating physical server separation.
Oh, interesting. So you can implement a multi-geo architecture where the EU site literally pings a server located in Frankfurt.
Yes, ensuring European user data never legally or physically crosses into a U.S. data center.
That's a huge legal benefit. And from an organic marketing perspective, I imagine it allows regional managers to hyper-target their SEO.
Totally. The search intent for sporting goods in Tokyo is vastly different from the search intent in Chicago. The geographic model gives local teams the autonomy to optimize their specific silo without interfering with the global brand.
But the maintenance alert on the geographic model is staggering, primarily due to the linguistic complexity.
It's a massive headache.
Let's say Apex launches a brand new carbon fiber tennis racket globally. We need an English description for the US site, an English description for the UK site, and an English description for the Australian site.
Right. And to a human, these are tailored experiences, using dollars versus pounds or slightly different spelling.
But to an AI web crawler analyzing the raw text, it looks like Apex just copy-pasted the exact same 500 words across 3 different domains.
And search engines disguise duplicate content. Historically, if an algorithm saw the same text on 3 different URLs, it assumed you were trying to spam the index.
So it would penalize your domain authority. To solve this, your engineering team must flawlessly execute what are called reflang tags.
Yes, the dreaded reflang.
I want to dig into that because reflang is one of those technical elements that routinely breaks massive corporate sites. How does it actually work under the hood?
And reflang tag is a tiny, easily corrupted snippet of HTML code that sits in the header of the page. It essentially acts as a localized map for the crawler.
Okay.
It tells the search engine, look, I am fully aware that the content on this US page is nearly identical to the content on the UK page, but I am explicitly declaring that URL A is intended solely for English speakers in the United States. So NUS and URL B is the canonical version intended for English speakers in Great Britain, which is NGB.
It sounds simple in theory.
In theory. But in practice, maintaining that matrix across thousands of products is a nightmare.
Right, because if a developer forgets a return tag or uses the wrong country code ISO format.
The entire chain breaks. The search engine gets confused, and suddenly your U.S. customers are seeing price neon British pounds in their search results.
Wow. So the geographic model demands meticulous, relentless technical oversight.
It really does. Which brings us to the third option, which radically shifts the perspective. The task or scenario model.
Okay, so this model abandons the idea of organizing by internal corporate structure or physical geography. Instead, it builds the architecture entirely around immediate user intent.
Yes, this is essentially reverse engineering this site based on why the customer showed up in the first place.
So for Apex Global, the primary navigation wouldn't say departments or regions, it would be a list of actionable verbs.
Exactly. Things like process a return, register a warranty, find a store, or download assembly instructions.
Silva points out that in the modern landscape, this model is absolutely devastatingly effective for voice search and answer-based AI tools.
It is. Think about how people actually use devices today. If a customer is frustrated with a broken Apex tint, they don't go to Google and type Apex Global Corporate Directory Customer Service subfolder.
No, they hold up their phone and say, "Hey Siri, where do I get a refund for my Apex tent?"
Right. And if your architecture is brief on the task model, you have an entire structural node dedicated purely to the concept of refunds.
And the AI crawler instantly recognizes that node as the definitive, frictionless answer to the user's query.
And it serves your page directly as the top result.
That's incredibly powerful. But the operational trade-off seems intense, because when you build a page entirely around a high-friction user task, you have to engineer the underlying infrastructure to survive massive, unpredictable traffic anomalies.
Yes. If we connect this to the bigger picture of site performance, this is where your architecture collides with your server capacity.
Give me a scenario where the task model breaks down.
Okay, let's say Apex Global issues a massive product recall on a popular line of bicycles right after the holidays.
Oh, that's a nightmare scenario.
Suddenly, 200,000 customers are trying to access the process of return task page simultaneously. If your architecture is task-based, that specific page becomes the absolute bottleneck for the entire corporate portal.
So your engineering team has to be obsessed with core web vitals.
Obsessed. Core Web Vitals are the strict performance metrics Google uses to measure user experience. Largest contentful paint, which is how fast the main content loads. First input delay, how fast the page reacts when you click a button, and cumulative layout shift.
Which is whether the page jumps around while loading, right?
Exactly. If that process of return page has a bloated, unoptimized hero image or relies on heavy JavaScript that takes 6 seconds to render under the weight of a traffic spike, the user intent is blocked.
The customer gets an error, they take to social media to complain, and the entire task model fails its primary objective.
And furthermore, tasks are often temporary. An Activate holiday gift card task is highly relevant in January, but becomes dead weight by March. The structural matrix requires constant, vigilant pruning.
That sounds exhausting. Finally, we arrive at the fourth blueprint, the portfolio model. This approach organizes content by specific archetypes or rigidly defined target audiences.
What Silva calls highly engaging knowledge silos.
Think of a massive media conglomerate, or returning to our Apex Global example, think of how a massive sporting goods company fragments its audience. A marathon runner has zero interest in the equipment needed by a deep-sea fisherman.
Exactly. The portfolio model respects that division. You create an entirely self-contained digital ecosystem for Apex endurance running and a completely separate, equally deep ecosystem for Apex Marine.
From a branding perspective, this is a dream. You create deep, immersive, hyper-relevant experiences. The customer feels like the site was built exclusively for their specific lifestyle.
But, and it's a big but Silva warns that for massive international corporations, the operational reality of managing a portfolio architecture is incredibly difficult because of taxonomic overlap and cannibalization.
Yeah, the boundaries of a portfolio are rarely perfectly clean. What happens when Apex launches a new line of advanced, sweat-proof smartwatches?
Right. Does that product live in the Apex endurance running silo because runners use them?
Or does it live in the Apex golf silo because it has GPS range finding? Or does it need its own entirely new Apex technology silo?
If you aren't careful, you end up duplicating the smartwatch product page across 3 different portfolios. And now we are back to the duplicate content problem, fighting ourselves for ranking authority.
So keeping the taxonomies pristine requires an incredibly firm, authoritative governance council within the company to dictate exactly where a product truly belongs.
So as we close the book on the foundational blueprints, the immediate takeaway is to mentally audit your own organization's digital presence. Which of these four models are you actually running?
Right. Is it a chaotic hybrid? Are you forcing a geographic model but failing to execute the reflang code? Are you attempting a task model but suffering from a bloated CMS that fails during traffic spikes?
Diagnosing your current model is the only way to understand the specific structural vulnerabilities you are currently exposed to.
Okay, so let's assume we have our blueprint. We've chosen our organizational model. We know the zoning laws of our digital city.
We have the plan.
But now we have to actually pour the concrete. We have to determine how deep the structural foundations should go. And this is a massive shift in how the modern web is being built. It brings us to a critical junction, the classic hierarchy versus the modern flat structure.
This debate is essentially tearing the information architecture community apart right now, because the traditional way we have built websites for the last 25 years is suddenly being exposed as a massive technical liability in the age of AI.
Let's start with the traditional methodology, the classic hierarchy. This is what basically everyone listening to this grew up with. It is built entirely on deeply nested subdirectories.
Think of how a physical file cabinet works, or how the folders on a Windows 95 desktop functioned. You have a main folder, you open it, there are more folders inside, you open one of those, more folders.
Right. So in a web context, you go to the Apex global homepage, you click a top-level directory called /products. Inside that, you click a subdirectory called /footwear. Inside that, /running. Inside that, /trail running.
It just keeps going.
And finally, 5 levels deep, you reach the actual page for the Apex Mountain Sprinter shoe. Now, to a human brain that is used to physically sorting paper into manila envelopes, this feels incredibly illogical.
It's organized. Everything is neatly tucked away in its designated box.
But you and Silva both argue that this deep nesting is actually a massive bottleneck today. Why? What is fundamentally wrong with the Russian nesting doll approach?
There are three critical systemic failures with deep classic hierarchies in a modern context. First, and perhaps most painfully for IT teams, it creates rigid, inherited permissions that are a nightmare to govern.
Give me an example.
Okay, let's say you hire a junior copywriter whose only job is to update the descriptions on trail running shoes. Because of how server directories work, if the vice president locks down the top-level /products folder for security reasons, that restriction cascades down through every subfolder.
Ah, I see.
The junior copywriter is instantly locked out of the /trail running folder unless an admin creates a complex, highly specific bypass permission. The hierarchy actively fights agile collaboration.
And what about the AI crawlers? How do they handle a URL that is 5 directories deep?
They hate it. This is the second failure. We go back to the concept of crawl budget. Search engine bots are efficient, but they're also fundamentally lazy.
Really? Lazy?
Well, mathematically lazy. When a crawler hits a site, it assigns the highest value to pages closest to the root domain. A page at apex.com/shoes is seen as highly important.
Okay, that makes sense.
But as the crawler has to dig deeper down into /products/footwear /running/trail running, it assumes the content is becoming increasingly niche and less vital.
Oh, wow.
Often, the bot will simply abandon the crawl path before it ever reaches the bottom layer where your actual money-making product lives. You're burying your treasure where the map refuses to go.
And the third failure is the sheer physical rigidity of the URL structure. If you need to reorganize the company, moving a deeply nested page changes its permanent physical address.
Exactly. If Apex decides that trail running shouldn't be under footwear anymore, but should be its own top-level lifestyle category, moving that page changes the URL string entirely.
So every backlink from an external blog, every saved bookmark, every internal link on your site suddenly breaks and returns a 404 error.
Unless you flawlessly execute hundreds of server-level redirects, the classic hierarchy is petrified wood. It cannot bend, it only breaks.
Which brings us to the revolution, the flat structure and the concept of content hubs. This model attempts to solve the rigidity of folders by essentially abandoning them altogether.
In a modern flat structure, you don't build folders within folders within folders. Instead, every single piece of content, every product page, and every article is essentially treated as an independent top-level unit.
They are incredibly shallow.
Very shallow. The URL for that trail running shoe might simply be apex.com/mountain sprinter.
Okay, wait, stop right there. I have a genuine, massive pushback against this concept.
I thought you might. Let's hear it.
If I take the 10,000 files on my computer, delete all the folders, and just dump every single file directly onto my desktop, I don't have a cutting-edge, flat structure. I have an anxiety-inducing digital jump drawer.
That's a fair point.
Right. If millions of pages are just floating around on the same shallow level, how is that not absolute chaos? How is a user supposed to find anything?
That is the exact visceral reaction most traditional database architects have when they first encounter flat design. It sounds like anarchy.
Yeah.
But the fear stems from fundamentally misunderstanding how the connections in a flat structure work.
Okay, explain it to me.
You were thinking of physical locations. Flat structures rely on semantic graphs and metadata tagging.
Break that down. What is the difference between a physical location and a semantic tag in this context?
Think of a classic folder hierarchy, like a physical house. A piece of paper lives inside a specific filing cabinet, inside a specific room. If you want it in a different room, you must physically pick it up and carry it there.
Okay, that's the classic folder.
Now, a flat structure operates more like a massive networking event, where everyone is wearing name tags. The pages aren't trapped in rooms, they are standing in an open field, and they are associated with centralizing concepts called content hubs.
Okay, so the hub is the organizing principle.
Yes. Picture a bicycle wheel. The content hub is the center axis of the wheel. The individual shallow pages are the spokes radiating outward. The hub page for running equipment acts as a central aggregator. It uses internal links and dynamic database queries to pull in every single page tagged with running.
So the product page apex.com/mountainsprinter isn't physically stored inside a running folder. It just has a metadata tag that says, I belong to the running hub.
Precisely. And this strategic difference offers a level of agility that a classic hierarchy can never achieve. Let's return to the reorganization scenario.
Okay.
Apex Global pivots. They realize the mountain sprinter shoe is actually being bought heavily by hikers, not runners. They want to rebrand it under a new outdoor adventure initiative.
If I was locked into the classic hierarchy, I would have to physically move the file, change the URL from /running/mountainsprinter to /outdoor/mountainsprinter, set up 301 redirects, update the sitemap, and pray I didn't break a critical sales funnel.
Exactly. But in the flat structure, the URL of the product page is just apex.com/mountainsprinter. That URL never changes.
Wow.
To move it, you don't touch the physical file location. You simply open the CMS, delete the tag running, and type in the tag outdoor.
And instantly, the database disconnects the spoke from the running hub and dynamically reassociates it with the outdoor hub.
Yes. No complex server permissions are altered, no permanent URLs break across the internet, no backlinks are lost, and zero server redirects are required. The architecture flows like water instead of snapping like a twig.
That is an incredibly elegant solution for a business that needs to adapt its marketing to sudden trends. But before anyone listening decides to go rogue and delete their corporate folder structure tomorrow, we have to highlight a massive, screaming system caveat that Silva includes in his article.
Yes, a very important warning.
He recounts a real-world disaster from early in his career where he applied this exact, brilliant flat structure to a major e-commerce project, and it ended in total catastrophe.
Total failure. He designed a beautiful, modern, tag-based flat structure, and the development team had to completely scrap it and rebuild it from scratch, wasting massive amounts of time and budget.
Why? If the flat structure is so objectively superior for agility and AI crawling, why did it fail so spectacularly in practice?
Because of the underlying foundation. The content management system, the literal software the company purchased to run their database, was antiquated.
Oh.
It was a relational database hard-coded to require a classic folder taxonomy.
Oh, no.
It simply did not have the back-end infrastructure to understand dynamic semantic tags or hub associations. It required a parent-child directory structure to function.
So running a flat, node-based architecture on a 1990s relational SQL database is essentially like trying to plug a modern high-speed USB-C drive into a cassette player.
That is the perfect analogy.
The theoretical data is vastly superior, but the physical hardware fundamentally lacks the receptors to process it.
Exactly. The lesson here is absolute. Before you attempt to modernize your information architecture into a flat structure, you must conduct a ruthless audit of your CMS capabilities. You cannot run a 21st century semantic web strategy on a platform that fundamentally demands 1990s folder logic. The software will reject the architecture, and the project will crash.
All right, so we have established our blueprint, and we have navigated the depths of our structure, opting for a flat, tag-based system if our technology allows it. But this raises the next massive hurdle. We rely on tags to associate content. But what happens when the human beings applying those tags can't agree on what words to use?
Oh, this is where it gets really messy.
We are transitioning into the third major challenge, the language trap. The brutal battle between how users naturally speak in the real world and how algorithms require us to speak.
This is where information architecture crosses over into linguistics and behavioral psychology. And it centers on the clash between folksonomies and controlled vocabularies.
Let's define the Wild West first, folksonomies. A folksonomy is essentially a system of classification that is entirely crowdsourced. It is user-generated metadata.
The most obvious everyday example of this is the hashtag on social media. There is no central committee dictating which hashtags are allowed on Twitter or Instagram. The users just invent them on the fly.
And we must acknowledge the sheer brilliance of a folksonomy. Its primary strengths are speed and inclusivity. It captures the cultural zeitgeist instantly.
Silva uses examples like the early days of podcasting or the emergence of blockchain. When a new technological concept or cultural movement is born, the community invents the terminology organically.
Right. By the time an official dictionary or a corporate standards board formally recognizes a term, the folksonomy has already been using it effectively for years. It allows the architecture to evolve at the speed of human conversation.
But, and this is a massive algorithm breaking but, what is beautiful and expressive for human beings is an absolute nightmare for a database. Silva highlights the crippling danger of ambiguity, and specifically a linguistic concept called polysemy.
Polysemy, that's where a single word or a specific phrase possesses multiple, sometimes vastly divergent meanings depending entirely on context, right?
Exactly. And in a pure, unmanaged folksonomy where anyone can type any tag they want, polysemy causes absolute chaos for search engines.
He uses a fantastic example in the source material. Imagine an independent tech blog where the writers and users are freely tagging articles. Because there are no rules, you end up with one article tagged Mac, another tagged Macintosh, and a third tagged Apple.
Right. And a human reader scrolling through that blog possesses the cognitive contest to instantly realize, these all refer to the same specific ecosystem of desktop computers created in Cupertino.
But a web crawler, a machine parsing raw text strings, does not possess intrinsic human context.
No, it doesn't. When it scans those tags, it sees three completely disconnected, unrelated strings of characters. Without a highly structured framework, what computer scientists call an RDF, or a resource description framework, informing the crawler that Mac is mathematically equivalent to Apple in this context, the blog's authority is fractured.
Explain that fracture. How does it actually hurt the site?
Well, search engines rank sites based on perceived topical authority. If an AI understands that you have 100 deeply researched articles, all clustered around the concept of Apple computers, it deems you an expert in that field and ranks you highly.
Okay.
But if your folksonomy scatters those articles across 3 unrecognized disconnected tags, the machine thinks you only have 30 articles about Macs, 30 about a fruit called Apple, and 30 about some unknown concept called Macintosh.
It decides you lack depth in any single subject, and your ranking collapses. Unmanaged language dilutes your digital authority.
To really drive this point home, the article dives into the heavily cited research of Louise F. Spiteri, a prominent information science researcher at Dalhousie University.
Spiteri's work is vital to this conversation because she isn't a traditionalist trying to ban user input. She is actually a massive advocate for collective intelligence.
Yeah, she helped break the elitist mindset that only trained librarians are qualified to organize information.
However, her empirical research proved that while user-generated tags are culturally valuable, a pure, unmanaged folksonomy violently fails the basic structural guidelines required by database systems, specifically the strict NISO guidelines for data structure.
She highlights an extreme version of the polysemy issue called the homograph problem, and the example she uses is the word port.
Think about a user typing the tag port into a search bar. What do they want? Are they looking for information on a fortified sweet wine from the Douro Valley in Portugal?
Or are they reading an article about naval logistics and shipping container management?
Or are they trying to troubleshoot a network technology port on a server router? A folksonomy cannot differentiate. It just lumps the wine, the boats, and the servers into one useless pile.
My absolute favorite example from her research mentioned in the source is the acronym RSS.
Oh, that's a great one.
Most of us in the digital space immediately recognize RSS as really simple syndication, the old web feed format for blogs and podcasts. But if you actually look at Wikipedia's disambiguation page, RSS has over 23 distinct globally recognized meanings.
23.
Yeah, it can stand for the Rashtriya Swayamsevak Sangh, a massive organization in India. It can stand for the Royal Statistical Society in London. It is a metric in statistics called the residual sum of squares.
So if your website relies entirely on users typing RSS into an unstructured tag box, your internal search engine and Google's external web crawlers are essentially playing a blind guessing game with 23 possible answers. And algorithms despise guessing.
And Spiteri also takes aim at the software development community for trying to invent lazy band-aids to fix this human language problem. Developers will often enforce rules like, you can't use spaces in tags, you must use an underscore, it has to be open source, not open source.
She correctly points out that those are simplistic, superficial fixes. Enforcing an underscore doesn't solve the underlying ambiguity. It doesn't tell the machine what open source actually means.
Furthermore, folksonomies fail to manage stop words. Users will organically create tags like the best laptops, including the word the. Stop words are essentially invisible noise to a database index, and they actively corrupt the search query logic.
So we arrive at the critical impasse. Unmanaged user tags are too chaotic for AI crawlers, but rigid folder structures are too inflexible. What is the actual technical solution?
Silva calls it the semantic solution. Disambiguation. We have to introduce a controlled vocabulary.
Disambiguation is no longer optional. It is a mandatory foundational step in modern technical SEO. Disambiguation is the deliberate process of mathematically removing the ambiguity from your data. And you do this by integrating a controlled vocabulary.
I want to break this down into actual mechanical steps. How does a developer or an editor actually implement this in practice? Let's go back to our tech blog example, and I am writing an article about the company Apple. How do I disambiguate that?
In a controlled vocabulary system, you do not simply rely on the raw text string APPLE sitting on the page. You explicitly mathematically link that local text to a globally recognized external authoritative entity.
You use back-end code to essentially say to the crawler, when I use the text string Apple on this specific page, I am explicitly referring to the corporate entity defined in the Google Knowledge Graph or Wikidata as the multinational technology company founded by Steve Jobs, and I am emphatically not referring to the agricultural fruit.
So you're literally handing the AI crawler a VIP backstage pass to a specific dictionary definition. What does that code actually look like?
The industry standard protocol for this is called schema.org, which is a collaborative vocabulary created by Google, Microsoft, Yahoo, and Yandex. Specifically, you use a relational property within schema called SAMAS.
Okay, so how does the SAMAS tag function?
In the JSON LD script running behind your page, you create an entity block. You define the type as organization, you define the name as Apple, and then you use the SAMAS property to insert the exact URL of the Wikidata entry for the tech company, which is Q312 in their database.
So the code physically points the machine away from the ambiguity of language and directly toward a standardized, universally understood database node.
Exactly. You are providing explicit mathematical context. The moment the AI crawler reads that SAMAS tag, all linguistic ambiguity vanishes instantly. The crawler no longer has to guess your intent based on keyword density. It knows exactly what entity you are discussing, which makes your content infinitely safer and more authoritative for top-tier search engine rankings.
Okay, that is a brilliant technical solution. We use schema.org and SAMAS tags to define our entities. But this brings us to a massive, glaring operational reality. The machine doesn't write the schema code. Humans do.
Yep. Someone on your staff has to actually sit down, look at the article, identify the entities, and manually insert the correct Wikidata links into the CMS.
Yes, the semantic web ultimately relies on human annotation.
Which transitions us directly into the fourth major pillar of our exploration, the science of annotation. Because we have to ask the terrifying question, what happens when the human beings tasked with doing the tagging are simply bad at it?
What happens when they are exhausted, undertrained, or just rushing to meet a deadline? We are moving from the theoretical rules of linguistics to the messy, empirical science of human error.
This is, without a doubt, the most critical part of this entire deep dive when we look toward the future viability of artificial intelligence.
Yep.
There is an axiom in computer science that predates the internet, but it has never been more relevant than it is right now. Garbage in, garbage out, G-go.
Apply that to what we were talking about. Deep learning models, generative AI, they don't possess native intelligence. They rely entirely on something called ground truth.
Ground truth is the verified, exact, human-applied label attached to a piece of training data. It's the absolute foundation of machine learning. If you want to train an AI to recognize a picture of a cat, you feed it a million pictures of cats. But the AI only knows they are cats because a human being provided the ground truth by manually labeling each image. This is a cat.
The algorithm then analyzes the pixels to learn the mathematical patterns associated with that label.
Exactly.
But if your metadata is corrupted, if your human annotators are tired and they accidentally label 1,000 pictures of golden retrievers as cats, or if our tech blogger accidentally uses the same AA's tag to link their MacBook review to the Wikidata entry for a Granny Smith apple, what happens to the AI?
The mathematical models begin to learn inauthentic synthetic dependencies. The neural network starts adjusting its weights to associate the physical characteristics of a dog with the linguistic concept of a cat.
And here's the terrifying reality that many executives failed to grasp. Sheer volume and raw computing power cannot fix bad ground truth.
No, it can't. You can throw $10 billion worth of GPU processing power at a dataset, but if the foundational human annotation is corrupted, the AI doesn't get smarter. It just becomes incredibly efficiently fast at being completely wrong.
To quantify just how badly humans mess this up, Silva introduces a major, very recent 2024 study. It is titled A Matter of Annotation, authored by researchers Holzman and van Leerhoven, and published in the journal Frontiers in Computer Science.
And what is brilliant about this study is that it didn't look at pristine data entry in a controlled lab. They studied how human beings actually annotate operational data in the wild, meaning out in the real world, sitting at their desks, dealing with Slack notifications and looming deadlines.
The researchers discovered that data annotation is not a simple data entry task. It is a highly volatile socio-technical process. Humans constantly battle a severe cognitive conflict.
Right. On one side, you have the data model demanding absolute crystalline precision. On the other side, you have an exhausted human worker whose daily workflow is being constantly interrupted by the sheer friction of the tagging process itself.
The study broke down how humans actually approach tagging into 3 distinct behavioral methods, and the results are staggering. Let's walk through them. Method 1 is in situ, or on-site annotation. This is doing it live, in the moment.
The study found that in situ annotation yields the highest theoretical precision, but it causes the maximum amount of workflow friction. Imagine an editor writing an article. Every 3 minutes, they have to stop writing, open a complex semantic tagging dashboard, search for the correct Wikidata URI, apply it, close the dashboard, and try to remember what sentence they were typing.
It shatters their flow state.
The frustration builds, and eventually human nature takes over. They start taking shortcuts. They guess the tags, or worse, they simply forget to close the HTML tags properly, which breaks the code entirely and invalidates the data.
Because in situ is so painful, most workers naturally gravitate to method 2, self-recall. This is the classic I'll just write it down later approach.
The editor powers through writing 3 articles in a row, and then at 4:30 p.m. on a Friday, they try to log all the metadata and semantic tags for everything they did that week from memory.
From a data integrity standpoint, self-recall is an absolute disaster. Human memory is highly fallible and incredibly susceptible to bias. We naturally round times to the nearest hour. We forget the nuanced specific entities we referenced in the 3rd paragraph of an article we wrote on Tuesday.
The researchers proved that relying on self-recall completely destroys the behavioral granularity that machine learning algorithms desperately need to identify true underlying patterns. The data becomes a smoothed-over, inaccurate approximation of reality.
Which leads the researchers to validate method 3 as the winner, time series recall. This involves taking the burden off raw human memory by using advanced visual pattern recognition tools post factum. The study specifically highlights software tools like MED.
The genius of time series recall is that it separates the deep work from the annotation work, but uses data to bridge the gap. Instead of interrupting their writing, the human annotator finishes their task. Later, they open a visual dashboard that has recorded their activity, perhaps showing a timeline of the text blocks they generated.
The human looks at this visual representation, instantly recognizes the patterns of their own work, and can apply the semantic labels accurately in batches.
The research proved that this visual assist elevates technical consistency and dramatically boosts what machine learning engineers call the F1 score. Specifically, it boosted precision by up to 8%.
For the data nerds listening, you know that an F1 score isn't just a simple accuracy percentage. It is the harmonic mean of precision and recall. It means the annotator isn't just identifying the correct tags, they are simultaneously minimizing false positives and false negatives.
In the realm of machine learning classifiers, an 8% boost in an F1 score is monumental. It is the literal difference between a predictive model that successfully deploys to production and a model that is scrapped as a failure.
But, and this is a massive warning light that Silva flashes in the article, there is a severe danger here regarding user experience, or UX. These advanced visual tagging dashboards, these time series recall tools, are incredibly complex. Modern visualization tools can actually sabotage the entire process if the user lacks formal technical training in taxonomy.
This is the paradox of powerful tools. If you purchase an enterprise-grade semantic tagging software and you put that visually complex interface in front of a junior copywriter who has zero training in ontology or information architecture, the interface completely overwhelms them.
The study explicitly found that when untrained users were forced to use visually complex schema tools, their tagging accuracy was actually worse than if they had just been allowed to type plain text tags.
The complexity induces panic, they start guessing wildly just to clear the screen, and they inject massive amounts of noise directly into the system.
Silva has a quote in the text that I think needs to be printed, framed, and hung in the office of every chief technology officer on Earth. A professional blind to standards inserts noise into the system. If you give someone a powerful tool they don't understand, they will accidentally destroy your database.
And this brings us to the existential threat that Silva is truly warning us about: model collapse.
Model collapse is the nightmare scenario for the generative AI era. It is a mathematically proven phenomenon. Model collapse happens when an AI model is forced to train on polluted data, synthetic data generated by other AI, or badly tagged human data, the exact kind of noisy, folksonomy-driven garbage we just discussed.
How does the collapse actually happen mathematically?
When an AI ingests corrupted ground truth, its probabilistic understanding of reality begins to narrow. It starts to forget what statisticians call the tails of the distribution. It forgets the nuances, the edge cases, and the rare but true outliers of human behavior. It only remembers the highest volume, most generic, often incorrect associations.
Over successive training generations, the variance of the model shrinks entirely. The AI essentially becomes mathematically insane. Its outputs degrade rapidly into absolute nonsense, and the model is permanently ruined.
This is why Silva is so incredibly adamant about data purity. A small, pristine, perfectly human annotated data set is vastly superior to massive, noisy, uncurated big data. It is infinitely better for an AI to train on 1,000 perfectly semantically structured articles than 100,000 articles full of ambiguous, guessed, folksonomy-driven chaos.
Quality over volume is the only way to survive the AI era.
Okay. We have covered a massive amount of conceptual ground. We explored the 4 organizational blueprints. We debated the architectural showdown between classic hierarchies and modern flat structures. We navigated the linguistic trap of polysemy and the necessity of controlled vocabularies.
And we just dove deep into the hard psychological science of human annotation error and model collapse.
Now, it is time to bring all of this theoretical and scientific discussion down to earth. We are going to execute the core promise of this deep dive. We are synthesizing everything into the semantic implementation checklist.
This is the actionable, practical masterclass. These are the steps you need to apply to your content management system, whether it's a massive bespoke enterprise portal or a specialized corporate WordPress architecture, right now.
Step 1 on Silva's practical summary. Implement strict NISO attribute filters.
This goes directly back to the database guidelines we discussed. You need to audit your internal site search engine and your faceted navigation menus, the filters on the side of your product pages. You must ensure your backend system mathematically decouples activities from properties.
Break down that logic for us. How do you separate an activity from a property?
An activity represents human user intent. It is what the user wants to do with the object. Verbs like buy, rent, download, compare, or repair. A property is the exact, unchangeable physical morphology of the object itself. Adjectives and nouns like red, 15-inch screen, carbon fiber, or 220 volt.
If your search database jumbles user intents and physical properties into the same unorganized tag cloud, the faceted search breaks. The user cannot logically narrow down their query, and more importantly, the search engine crawler fundamentally misunderstands what the page actually offers.
You must architect the backend to separate what the entity is from what the user can do with it.
Step 2 on the checklist. Enforce the 2-level rule. This is a direct, aggressive attack on that classic hierarchy bottleneck we dissected earlier.
Yes. You must mandate the retirement of deeply nested subdirectories. The rule is absolute. Your core URL category should only go 2 levels deep. Main category, subcategory. Stop apex.com/shoes/running. Nothing deeper.
But practically speaking, how do you apply this if you manage a site with 20,000 individual products? How do you prevent going 3 or 4 levels deep?
By aggressively utilizing the flat structure principles we discussed. If a subcategory is getting so massive that you feel the urge to build a third level of folders, that is the system telling you the category is too broad. Do not build the third folder. Instead, break that content out into a massive, structurally shallow page or even an independent microsite and link it back to a centralizing content hub.
By enforcing the 2-level rule, you keep your URL short and permanent, you make administrative permissions incredibly manageable, and you guarantee that AI search engines can index every single product quickly because absolutely nothing is buried 10 clicks away from the homepage.
Step 3. Proactive ambiguity management. This is the direct cure for the language trap.
Do not ever let a search engine crawler guess your contextual intent. It is your job to define terms clearly within the prose of your text, but more importantly, you must architect the disambiguation under the hood using structured markup.
Let's remind everyone of the polysemy issue. The source text uses a brilliant example in Portuguese, the word bateria.
Exactly. In Portuguese, the word bateria can translate to a musical drum kit, or it can translate to an automotive car battery. If your e-commerce site sells auto parts, you cannot rely on the AI to figure that out purely from context clues. You must proactively manage that ambiguity.
You must use contextual entity links, like a specific Wikidata URI, nested within your schema.org SandyS markup, to explicitly declare to the AI, this page is strictly about the automotive power source and has absolutely zero relationship to the musical instrument. Ambiguity is the enemy of AI visibility. Disambiguate proactively.
Step 4. Extensive training. Based on the Holseman and Van Leerhoven study on human annotation error, this might be the most crucial operational step on the list. You cannot just install a semantic plugin and hope for the best.
Software is entirely subservient to the competence of the operator. If your IT department installs a top-tier enterprise SEO software suite that allows your editorial team to assign complex relational ontologies and schema tags, but you do not spend the budget to explicitly teach those editors what those ontologies actually mean, they will panic.
And when humans panic, they guess. And when they guess, they corrupt your ground truth, sending your system hurtling toward model collapse. You must invest heavily in data literacy and taxonomy training for your content team before you ever give them access to powerful semantic tools.
Finally, step 5. Vocabulary hybridism. This is about establishing a peaceful, functional harmony between the rigidity of the database architects and the fluid reality of how users actually speak.
You cannot rely purely on the chaos of a folksonomy, as Fidery proved, but you also cannot arrogantly ignore the organic, evolving language that your actual paying customers use. The architectural solution is hybridism.
You use professional, rigorously controlled vocabularies to build the primary structural skeleton of your site's navigation. The experts define the core taxonomy.
But then you deliberately open up a monitored secondary space.
Yes. You vigilantly monitor your internal site search query logs, you watch the folksonomy in real time, you observe the daily slang, the newly invented acronyms, the evolving linguistic trends of your users.
When a new term organically emerges, say your users start searching for kicks instead of running shoes, you do not let the term run wild and create its own chaotic tag page.
Instead, your taxonomy governance team captures that slang, maps it internally to the controlled vocabulary, and integrates it into the database as a recognized formal synonym for running shoes. You achieve the rock-solid structure of an expert system, perfectly blended with the cultural agility of a crowdsourced folksonomy.
Now, connecting all of these practical steps to the ultimate future of the semantic web, the expert in our source article, Silva, points to an underlying technology called the SELO-S bridge.
SOS is an acronym that stands for Simple Knowledge Organization System. It is a highly specialized data sharing standard developed by the W3C, the World Wide Web Consortium, which is the main international standards organization that essentially dictates how the internet functions.
I want to understand the mechanics here. Why is SOS the ultimate key to making this entire semantic checklist actually function on a global scale?
Because SOS acts as the universal translator. It is the technical bridge that takes those informal user terms, the hybrid slang and folksonomies we just mapped, and mathematically translates them into linked data and RDF formats that machines natively understand.
SecOS uses specific relational tags like SCOS broader, SCOS narrower, and SCOS related. It allows your internal database to tell a global AI, hey, the slang term kicks is SCOS related to our controlled entity footwear.
By adopting SCOHOS standards in your backend architecture, your corporate taxonomies cease to be isolated. proprietary islands of information. They become universally interoperable. They become instantly mathematically understandable to any global AI agent parsing the semantic web. Implementing ScopeOS fundamentally future-proofs your entire digital operation against the evolution of search.
So, let's synthesize the journey we've just taken. We started by acknowledging a painful reality. Digital clutter carries a massive, invisible cost, exhausting AI crawl budgets and infuriating human users. We learned that to fix it, we have to deliberately choose a foundational blueprint, an organizational matrix like the department, geographic, task, or portfolio model, and deeply understand the unique maintenance vulnerabilities of whichever path we choose.
We then explored the structural evolution, realizing that deeply nested classic hierarchies are a liability in the AI era, and that transitioning to a tag-based flat structure using content hubs provides massive agility, provided, of course, that your underlying CMS isn't a relational dinosaur that will reject the upgrade.
We navigated the linguistic minefield of polysemy, learning that while user-generated folksonomies are culturally fast, they create algorithmic nightmares that must be actively contained through explicit schema.org disambiguation.
We dove into the rigorous science of data annotation, seeing empirical proof of how bad interfaces and cognitive friction lead to human tagging errors, which pollutes the ground truth and pushes artificial intelligence toward the catastrophic mathematical degradation known as model collapse.
And finally, we armed ourselves with a 5-step implementation checklist, enforcing NISO filters to separate intent from property, rigidly applying the 2-level rule to shorten URLs, proactively disambiguating entities, mandating data literacy training, and utilizing SCOSO to create a hybrid vocabulary that bridges human slang and machine logic. The ultimate takeaway here is that profound information architecture is exactly like the concrete foundation of a massive skyscraper. It should be entirely, completely invisible to the person walking through the front doors, but it must be structurally flawless and mathematically infallible beneath their feet.
And that leads to a final, somewhat unsettling thought that I want to leave you with today.
Mm-hmm.
We've spent this entire exploration talking about corporate portals, e-commerce taxonomies, and global AI web crawlers. But this technology is rapidly moving inward. We are actively entering an era where AI agents, like advanced copilots, are beginning to locally parse, summarize, and interact with our personal hard drives, our thousands of unread emails, our chaotic desktop folders, and our personal notes.
The AI is no longer just trying to index a website, it is going to try to understand you.
Exactly. The AI is going to try to build an ontology of your personal life based on the files you provide it. So we have to ask ourselves a very uncomfortable question. Are we inadvertently causing a personal model collapse through our own messy, disorganized digital habits? If an AI were to read your personal hard drive or scan your company's internal Slack channels tomorrow morning, what bizarre, chaotic, completely unstructured ground truth would it learn about how you operate? Are you building a solid semantic foundation for your own data? Or are you just piling files into a massive digital junk drawer and hoping the algorithm can somehow read your mind?
That is a brilliant, slightly terrifying question to mull over. So the next time you navigate a frustrating website or even just save a randomly named PDF to your desktop, I encourage you to look at those files, those links, and those menus differently. Do not just see them as buttons. See them as the visible, tangible edge of a vast underlying semantic web. Treat your data with structural respect, and the machines might actually understand what you want them to do.